I would like the rest people to join us before we start the class proper. This class is for 5 p.m.
Yes, sir.
All right.
Can you hear me, sir?
Yes, I can.
Okay. While we wait, can we start with our take home from the last class?
All right.
So we can
That's
keep the
fine.
class engaged.
Okay. Yeah.
Yeah, thank you.
In no particular order, I can see 10 participants already, 10 students in the class. In no particular order, let me see who are with me right now. I think Chuka joined very early. I have Daniel Aja. So Chuka, I would like you to share with us your take home from the last class, how it has impacted your career or your profession so that others can learn from it. Chuka, I would like to hear from you. Thank you. Chuka, are you with us? Chuka Ren, are you with us? Okay, I can see additional. Additional, can you tell us your take home from the last class and how it has impacted your career so far? Additional. Please kindly unmute your microphone in case you are talking so that we can hear you. Additional, are you here? Mosumola. Okay, Chuka, if you are back on your desk, can you please tell us, share with us your take home from the last class and how it has impacted your career so far? All right. Daniel Equere, kindly tell us your last experience from the last class, your take home, so that others can learn from it. Mr. Daniel.
Good afternoon, sir.
Introduce yourself by telling us your name.
Good afternoon. My name is Daniel Equere.
Welcome.
My take home from last class was interesting. We learned about facility maintenance strategies. We were educated about different types of maintenance strategy, like the reactive maintenance, preventive maintenance, predictive maintenance, and reliability centered maintenance. One of them that got my attention most was the predictive maintenance. There is something that happened in my office some time ago. We have been running on a genset which is about 350 kVA, but data were not collected, all that. I believe you can. Hello.
Please continue. If you are not talking, kindly mute your microphone.
Can everyone hear me?
Yes, we can hear you.
Okay, the emphasis is predictive maintenance. How is very
Please
useful.
mute your microphone if you are not the one talking.
I'm talking about predictive maintenance, how is very useful in a maintenance strategy. It's a very useful maintenance strategy because it focuses on data driving. It's a data driving strategy suitable for complex equipment. Something happened in my office some time ago. We were running on a genset of 350 kVA. The electricians were asked to let us know what is the load capacity that we are running in the estate. What they did, they went around and captured all the capacity of the instruments that we use, the kilowatts, and they end up telling us that the whole load that we are using in the estate is about 400 and something kilowatts. Then, because of that, we should need a 500 kVA generator. Not knowing that not at any point at time, any of these instruments, all of them work at the same time. So the company acquired 500 kVA genset. It was not even up to 2 years. The genset started having problem. We didn't know what happened. Then, but when we now installed a system that monitors the load, monitors the capacity and the consumption, power consumption, we started taking those records. We now came to realize that there is no point in time that the load in that estate was up to 20% of the capacity of the genset. That means we have been running on underloading the genset, which what we would have needed would have been, let's say, 200 kVA, which is very okay for the load. But we were running 500 kVA, and the load we were having was not up to even 20% of the capacity of the genset, which is very bad for the genset operation. So that is why I'm saying predictive maintenance is very useful, because it will give you accurate information, let you know what to do, and to take a pre-informed decision for the future. Thank you.
All right, thank you so much. Thank you so much. Thank you so much. Yeah. I'll take more person to share his experience so far, so that we can start. It's almost 5:10. Amir, your take home from the last class. Amira Hassan, kindly tell us your take home from the last class and how others can benefit from it. The floor is open to you. Amira Hassan. Unmute your mic.
Yes, good evening. Good evening. I'm so sorry. I would not be able to respond right now, but just I need a few minutes, then I'll respond. Thank you.
All right, no problem. Okay, Innocent, if you're in the call, kindly let us know your experience, how others can benefit from you, Mr. Innocent.
Good evening, sir. Good evening. Good evening.
What did I do? Sorry.
Good evening.
You are loud and clear. Go ahead, sir.
Ready?
Okay. I just wanted to share my take home for our last class on the facility maintenance strategy. In our last class, I had to understand that we have 3 types of maintenance strategy by which we apply to ensure that we optimize the state of our equipment. I was taught on how we can carry out preventive maintenance strategy, reactive maintenance. I'll get back to you. reactive maintenance, and I think one other one skipped my memory at the moment.
All right,
But
thank you.
I was able to understand these two set of maintenance strategy as regards equipment.
All right, thanks for sharing with us. Thank you so much for the brief experience you've had so far. And we want to go into today's class. I would like to welcome everyone into this class, and I need your cooperation so that we can finish on time and enjoy the class. Today's class, as you can see from the screen, is electrical power system maintenance. Why is it important? Why is it so important for you to maintain your electrical power system? So all of this you are going to see at the here and learn from at the end of the class. So you will see why the reason why you should take your maintenance seriously. When you maintain your equipment, like you have said, you will spend less on corrective maintenance. Planned preventive maintenance is very key. When you do what you are meant to do, if you don't compromise standard, you will spend less. One of the reasons why you are employed as a facility manager is to bring down costs, not compromising standard, to increase return on investment, and to minimize costs, minimize risk, and downtime in your facility. So today's class is focused on electrical power system maintenance. So you're going to see who you'll be interacting with as your facilitator. We have the housekeeping ground rules. We have various modules that we are going to be dealing with, summaries and assessment. At the end of this class, we're going to have an assessment to really know if you actually participated. So this is me, my profile, your facilitator for this class. This is my profile thus far. And my name is Mr. Abel Iyoriowe. Let me pronounce it for you. These are housekeeping rules. So I need to meet you so that I'll know who I'm dealing with, the student I'm dealing with. So eliminate possible distraction or interruption that will make you not to concentrate in this class. So one conversation at a time. You have to unmute your mic when you are permitted to do so. You are expected to mute your microphone all through this session, except you have requested and have something to share with everyone so that they can benefit from it. So we have a break time of about 5 minutes so that we can freshen up and come back to the class. That's housekeeping. So these are the course objectives. What you stand to gain at the end of this class. At the conclusion of this course, participants will be able to understand the basis of electrical energy and power. You're also going to know how to carry out load analysis, like the first students said. They made away with 350 kVA and settled for a lesser one or a higher one. So after this class, you will know how to do it yourself, and your technician will not make mess of you. We have power factor as a function of generator sizing determinant. So you use power factor to determine the size of the generator that you are recommending for your client or your customers. Various generator components and their functions. The importance of equipment maintenance. Why do I need to maintain my equipment? Transformer and its function, And the last part is earthing, and it's important. Why is it important for me to earth my building or my entire installation after all said and done? So the reason why you should earth your system. So all of this you are going to see at the end of the class. Module 1, definition of power. What is power? Power generation as a network of interrelated equipment. So power generation is a network of equipment. One equipment, generator alone cannot do it. It requires cabling, changeover, isolator, contactors, circuit breaker, and co. It's a network of arrangement that has substation and other equipment that is required to generate your power. We have sources of power where you have solar, hydro, gas, wind, and so on. Type of power, we have direct and alternative power. Direct power is used for sensitive equipment in the building, like your CCTV camera, your PABS, and textile, and so on. While alternative power, which is not that clean, can be used to generate our three-phase equipment like lift, pumps, that is industrial pumps, your other equipment that does not require more attention. So module 2, we focus on load. What is load? Conductors, electrical installation, and protective devices, and their usefulness. Why do we prefer circuit breaker over fuse, reliable fuse? We have the radar system of installation and the ring system of installation. The disadvantage of radar over ring will be dealt with this evening. We have the distribution board and circuit breakers. Why is distribution board necessary or important in my facility? Why do I need circuit breaker of various sizes to power my equipment as they are being rated? Module 3, we focus on generator maintenance and diesel management. You know, generator was regarded as our backup source of power, alternative source. But today in Nigeria, generator is the major source of power that every company relies on. So it is good you pay attention to your generator so that you can remain in business. EKDC or IKDC or Abuja, whatever, are now being used as backup. It's when they like, they supply you. When they don't like, they don't supply you. So your reliable equipment for your operation is generator diesel and diesel management. So that's why it is deemed fit to impute it in this course so that you know how important a generator and diesel is in your facility. But before we focus on earthing and grounding system, importance of earthing. Why do I need to earth my building or my facility? And the last aspect of this module or this course will be assessment. All right. So this is an overview of how a generative plant looks like the gas turbine, the gas system of electricity generation. So this is it. Most of you that have been to where you have gas station, this is how a gas can be used to power to generate electricity. What it requires is a turbine that keeps rotating, just like a small alternator in your generator. As long as fuel is coming into the carburetor and the engine flywheel is rotating, electricity is generated. As long as that alternator and rotor and stator are moving against each other, electricity will be generated. So gas also can produce that motion by injecting air into the shaft of a turbine. As long as that air is coming from the pipe that you are seeing, electricity will be generated. So So what is power system? Like I said, the interconnection of electrical component for supply and transfer of electric power from where it is generated to where it is needed. The operation of power system generation, the process of transforming energy, that's mechanical energy, into electrical form. So electricity is transforming electrical, that's mechanical energy, like that turbine is coming, the breeze or the wind is coming through the gas and set the turbine through the shaft on motion. As long as that pushing is there and the turbine is rotating in the right direction, electricity will be produced. So it's a process of transforming mechanical energy into electrical energy. That is why you have two components of your generator, the engine side and the alternator side. We'll get there and you know better when we get to that way. We have the substation. The subsystem produces electricity. This is how electricity is generated. Let's say this is Kainji Dam. Many of you that have been to Kainji or Shiroro Dam or Egbi Dam here, or Jeba Dam. So what is here inside this place is a turbine, a big turbine that have shafts. So we use natural system to produce electricity in Nigeria, mostly the hydroelectric system. So there's a dam that is built, and that water is falling from up and rotating the shaft of a turbine that is so big. As long as that water is falling on it, the electricity will keep producing. Just like your small generator at home. Once you set it on motion, that shaft is producing, rotating the alternator in that small generator. The same principle applies to the bigger one. It's a continuum flow of energy. So electric power is being produced here. You don't transmit power, you transmit voltage, because it is very expensive to transmit power. What you do is convert it to voltage, where you have 11 kV transformer, 33 kV transformer, and so on, depending on what you are producing. This turbine can produce a lesser value or a higher value. What you need is a power transformer that can step down the transformer, the value of the voltage, the power that you have produced, or step it up. A transformer either step up or step down. So if the volume of electricity that you are producing is very low, the transformer, you need a step up transformer that will step it up. And if it's very high, you need a step down transformer that will step it down. So it is being modified here and sent to this transformer. This is what we call power transformer that does the modification. It is modified to a level that can be transmitted through a long distance that is required. You can see this tower. They are seen when you travel on Nigeria roads. So they are used for high voltage transmission. You have the 33 kV, the 132 kV, and 330 kV along our Nigeria roads. So what you are producing may not be useful if it's not further modified to the end user. That's where you have another substation that will step it down from a higher value to where it can be tolerated. You can see this pylon, this tower. They are very far, either inside the lagoon or inside the bush where nobody can have contact with them. But here, it is further stepped down to 400 or 415, and to the residential 200 or 240 volts. That is the operating voltage in Nigeria. 400 or 415 for three-phase, and 200 or 240 for single phase. So this is how electricity is generated. Even in your facility, you see a generator at the corner of your building or a transformer. So they are brought in. From there, they are taken to where we have need for them, the electricity, where the consumers are. So like in production, a producer have not produced anything if the consumer have not satisfied that what they have produced is fine until it get to the table of the consumer. Not only get it to them, when they derive satisfaction, you may be producing electricity and it's burning out your bulbs, spoiling your equipment, spoiling everything in your building, and the cost is being taken off. So your primary purpose is to pay attention to what you are producing and what you are feeding into the building. So it's very important. So those are the things you need to pay attention. What voltage are you generating? Is it the standard voltage? What frequency are you operating on? Is it the standard frequency? Our frequency here in Nigeria is between 48 to 52. Anything outside that is out of phase. The same thing with voltage production. Between 220 and 240, between 200 and 240 on a single phase, and on a three-phase, as line voltage, is between 400 or 380, yeah, 380 to 415. So these are the standard operating voltage we have in Nigeria. Electric power is a product of the current and voltage. You should know what is responsible for the electricity generation. The current and the voltage, multiply them together, it gives you power. Power is equal to IV, voltage times current. So we have direct current. Direct current is what you produce from your battery. It can also be an alternative current can also be rectified to a direct current through a diode or a rectifier. That's why in your generator you have a rectifier, a diode. They call it rotating diode that gives constant supply to your battery and to your charging system. If they are bad, your generator will be shutting down. I know many people have come across rotating diode. So alternative current can be converted to direct current, vice versa, and direct current can be converted to alternative current. So direct current provides constant current and voltage. DC, you have clean power, almost 100% clean. That is why they are recommended for our IT equipment, our PABS, tungsten that has no reason to be distorted. We have most computer, like your battery, your computer, converts the AC current, that's the alternative current, into a direct current, which your computer make use of. If you operate your computer with raw power or alternative current, sooner or later, the power pack will go bad. You know how much is it to replace a power pack in your computer, not to talk of the IT equipment. So it is very important for you to pay attention to your batteries in your facilities, because if you don't pay attention to them, any value can go in and spoil that battery, and you are incurring costs instead of reducing costs for your organization. So we have alternative current. They are transmitted over long distance, which the one we saw here. This is alternative current generated from the turbine. So they are transmitted over a long distance. They are generated through an alternator. And equipment that make use of these are the refrigerator, your air conditioner, and pumps, etc. Power system have one or more power sources. Like I told you, we have the hydroelectric power system. We have wind turbine power system. We have gas turbine power system. We have solar, which is so common in Nigeria now. It now depends on what you want and how you want it. There are some that require uninterrupted power supply. You can get that from solar. And mind you, the disadvantage of solar solar has its own disadvantage, just like every other power system has their own disadvantage. We have load. What is load? Anything that draws current to function, to operate itself, is called load. like your fan, your light, your computer, your washing machine, your microwave, and all the things that require current to be driven is called load. Load ranges from industrial equipment to household appliances. Load has different rating, different capacity. That's why they will say, how many horsepower is that AC? Say, oh, 7.5, 2.5 horsepower, 2 horsepower, 1 horsepower. So loads are rated in various capacity so that you know which one to go for. Electric iron, there are electric iron that are 2,000 watts. There are some that are 0.75 watts, and as the case may be, it now depends on what you want to get and what you are looking for. So load expect to have a certain frequency. They have frequency as well. Like I told you, there's a range to which our loads operate in terms of frequency. We have between 48 and 52. Any appliance must have a specific wattage. That's the power rating. And power quality must be considered. So what kind of power are you feeding your equipment? Are they overrated? Are they abnormal? So you have to put all these into consideration. So when you are able to manage these parameters well, your equipment will last. The last part of your equipment will increase, you reduce cost, and you minimize risk. If the voltage you are bringing is like 250, 260 single phase, and you allow this voltage to go into your facility, they will call you from home that your building is on fire because that voltage is pretty too high. So you have to monitor the voltage value, the frequency, the power, like your generator that man said that it was shutting down or is malfunctioning because they didn't size the power properly. The technician just gave parameters and you follow suit, and before you know, you start having problem. So if you pay attention to all of this, as a facility person or as a technical person, you will bring down your cost, you will reduce risk, and maximize stakeholder investment. Conductors, they carry electricity where they are generated to where it is needed, like the wire you see. They call it cable, armor cable, and co, because the generator cannot fit itself. You have to run a cable from it to where you will change over, and from changeover, you start distributing. So that's why I told you electricity is a network of apparatus that must be well site designed and integrated. We have the capacitor and we have the protective device. They prevent damages during failure or injury. A typical protective device is the fuse, but fuse is no longer in use because many people have abused the use of fuse. You see a technician will tell you give him money to go and buy a breaker. Before you know it, they'll go and get the fuse, rewire it, put a cable around it, and plug it. It will give you light, but it's not serving any purpose, and it has endangered your facility. When there is fire or abnormal voltage, instead of that fuse to cut off, it will not cut off. It will allow the passage of that surge into your building. Before you know it, there is fire in your building, equipment is blowing off, things are going bad. You will ask yourself, they will ask you, why are we spending so much? Because you did not pay attention to what the technician have used. If you use a precise size of a precise breaker as rated or as indicated, the breaker will open whether you are there or you are not there. The breaker will open. That's why we recommend circuit breaker of a rated capacity to be used in your distribution or to distribute your load. With this, the cost might be high at the initial stage, but you are saving costs on the long run. As a facility person, you are looking at strategic management, not just tactical, like the technician would do. That's why you are there to monitor what they are doing. We have power electrode, capacitor, and reactors. They are used to reduce current demand on power system. When you have this in place, your bill at the end of the month will reduce because capacitor store charges. They store charges, I mean. It's like your fan, your AC. Then if you want to really start your AC or your chiller, you need a very high rating capacity generator to power just 2.5 horsepower. But with the help of it helps us to start the equipment without stress. So capacitor helps to reduce the cost of energy at the end of the month. So you pay attention to them. If the technician said that the capacitor is bad, please change it. We have in bigger company where they have capacitor, but a room dedicated for capacitor. What they do is to start up process beforehand. You don't need to stress yourself. So that's why your generator can run smoothly, your transformer can run smoothly. But if these are not in place, your bill will go up. People will ask, why our bill going up? As a facility manager, you have to check, right? If you have not checked before, check what you have in place. These are the ways you can reduce costs without compromising standard in your facility. What I'm telling you is what I have experienced. I'm just telling you so that you pay attention to them. Everything is...
you know, you say you come on, you're not going to be enter the staff boss. So you just make a follow.
Please mute that guy that is talking. Mute the guy that is talking. You should know you are in a class.
Oh, that's
me. Mute the guy that is talking, please.
No, the only change I think you continue.
All right, thank you. So we have power electronics. They convert, like I said, we have the diode that rectify alternating current as AC power to DC power is vice versa. They are semiconductors devices. We have the switches quantity of power ranging from few hundreds watts to several hundreds of watts. Like your reading lamp is one of such. So where you can dim the light when you want to sleep. When you want to read, you also increase the intensity of the light. So these are measures put in place to make sure you don't waste energy and at a cost. We have residential power system. Like I show you have both commercial and residential. Residential, they use lower voltage, while the commercial use higher voltage, where you have three-phase industrial motors, like your industrial borehole, your lift, your motor, and so on. Depends on the facility that you are managing. So this is distribution board I told you about. This is the breaker, rated in various arms. We have 5, we have 10, we have 15, we have 22, 20, 32, 63, and so on. So you don't, when you overload the breaker, it keeps tripping and it will go bad easily. So you take it from the distribution board to where it is needed, like your AC, you use like, let's say 20 amps to protect your AC. So from there, you take to where you have your AC, your fridge, your microwave, and so on. So breaker, circuit breaker is what we use these days. And yeah, fuses are still used. Like the rewirable fuse should not be encouraged in any facility because technicians, they don't know what you know. That's why you are here. That's why you are here to teach them what they need to do. Nobody should rewire a fuse, irrespective of the pressure that is before you. Never you rewire a fuse because you don't know the rating and you don't know when it will protect and when it will not protect. Instead, stick to circuit breaker. It trips whether you are there or you are not there. And when you come, when there is a trip, ensure you check what was responsible for the trip before you set it up, before you reset it. So don't just go and reset it. Ensure that something that tripped it is unraveled or is checked and established. Then if there is need to correct it, correct that fault and clear it before you go ahead and reset your system. I told you about the ring and is a radial. Ring circuit system is where you loop from one point to another, undermining the source of that supply. You are using a 2.5 mm cable to get a supply to where you want to distribute. You don't put it into consideration the size of that cable. Or like most developers do, they will start looping from point to point, from point to point. And before you know it, extension is attached to that socket where you plug your if it's an office, you plug your water dispenser, plug your portable fridge, you plug your, what's it called, photocopier. You plug so many things there, even your fan, and overloading that system. Before you know it, maybe if you pass it through your ties, underneath your ties, there will be a kind of heat because electricity comes with heat. Those cables will melt and you start breaking your ties. Are you really saving costs? But the developer have done what they needed to do because nobody was monitoring them. Now, as a facility manager, you are left with problem that you are now recommending your client to open the ties. The ties that means we are going to replace the entire tie. I encourage people to desist from ring circuit breaker. I've had that experience severally. Where people have to break ties and start replacing. So the best bet, first and foremost, is the radar installation, where you distribute from your distribution board to where it is needed to all the appliances. The initial capital might be high, but on the long run, you think strategically. On the long run, you are actually saving cost. If you spread that across the number of years, you will see how much you have saved and the risk that you have minimized. So duty is to minimize risk and optimize cost. So this is radar from distribution board, consumer unit to where it is needed, like your AC. Never you loop AC switch. Let it run from distribution board to the AC point. The same thing with microwave. Anything heating element, don't attach anything to it. A standalone, because if you do, it will start tripping. Before you know it, it affects your circuit breaker. And these are the ways you can reduce cost in your facility, paying attention to details. So in electricity, we have, in electrical engineering, we use symbols to represent our equipment, like the ceiling fan. You may not, if you are given a drawing, a building drawing, you will not see ceiling fan the way it is. You will not see fluorescent the way it is. You will not see socket the way it is. You are going to be seeing symbols. So that's why we encourage you to familiarize yourself with these symbols so that as a facility manager, you are also a project manager. You can interpret drawings. So try as much as possible to familiarize yourself with these symbols. So these days, computers have made it so easy. So just check online and see, try as much as possible to master as many as you can master. So like this black thing, like looks like Ludo, is a silicon. We have fluorescent of 4 feet, fluorescent of 2 feet, socket of 2 ways, and a 1 way, switch, of 2 ways and 1 way. So in designing, you have to consider the following. You have to consider the following when you are designing a building. Type of supply and earthing arrangement. What kind of supply? Is it single phase? Is it 3 phase? You have to know that. So that will determine the kind of equipment that you are going to buy. If you buy a 3 phase equipment, when you have single phase equipment, it will not the supply that is coming into your building or that you already have in your building, so that you know how to procure your load. Ambient temperature, like your generator. Is it a soundproof or a basic? Like place in the north, you don't need a soundproof there because of the temperature. Like in Lagos, you might consider soundproofing because the temperature is fair and the environment as well. Possibility of fire. You don't need to site your site close to a gas station or a filling station. Extent of mechanical protection required, additional protection required. You have to know that. Provision of feature modification. This is almost put on to. They just, like the man has recited his experience so far in this course, that changed generator from 350 to the kVA that they settled for. So the people that bought the 350, they have reason for buying it because they may consider future expansion. We may need to expand this building to accommodate our procurement unit or to accommodate our social unit. So you don't just give exact specification when you are doing load analysis. You create room for allowance, expansion. The probability of future extension, provision for future modification needs to be considered. The relative cost of various alternatives. For example, what alternative should I put in place in case this plan A fail? That's why you have people putting solar generator.
That's one thing when me I try for like 2 days, but today now I don't move on. You know, if you come on 2 hours,
please mute that man. Mute the man, please. All right, thank you. So these are the things you consider when you are carrying out design. You don't just stick to exact. You create plus or minus 5 or plus or minus 10% when you are recommending to your customers. Electrical maintenance is also a factor. The first condition is the ability of cable to carry its required load. It's not advisable to compromise standard. Sockets use 2.5 mm. Light point can use 1.5, 1 mm, but socket don't compromise it. From the consumer unit to the distribution board, you use like 60 mm or 4 mm, 4 mm that will carry load from your consumer unit to your distribution board. So you never compromise standard. All conductors must be provided with excess current protection, that is fuse, circuit breaker, etc., and also with means of isolation. So every cycle must have means of isolation. The switch gear, the control switch, the changeover. So it is sectionalized. So you have to have all these things in place. In case there's fire, the one that is closer to you, you knock it off. So you have secured your thing. But if there's no isolation, isolating means or isolation means, you end up endangering that house or your facility. Portable appliance testing. Why do I need to carry out tests in my facility? When you carry out tests and record them, you are creating a database for your entire team. You may be there or you are not there. If the need arises for your subordinate or your team to have a look of what is going on, what they need to do is to check what maintenance test, what tests have we carried out on this equipment. So you have a logbook that shows all the tests that you have carried out, like the LT system. You test every interval, like your taking of readings on your generator, you write them down. If you are deviating from the normal, you know that something is wrong. So like I told you, a certain frequency that must be observed between 48 and 52. If you don't put them down, if you don't carry out those tools that are used to read frequency, they are mounted on your generator. Your AC, they are mounted there, those sensors. So if they are going out of phase, your voltage value is going out of phase. It's going to 260, 280, and you are not monitoring. If you don't have means to test this thing and monitor them, you are at risk. Your cost will go high, the building is at risk, there will be no return on investment. You keep spending. This thing has burnt. Let me change it. You change. Tomorrow is bad again. But if you have history of what you have been doing, so you can just check, oh, why is this voltage going bad? It goes too high. You check. Maybe the AVR is not regulating well. Maybe there is a partial contact that is coming and going, or low voltage, as the case may be. So if you have history of what you have done, documented, you will spend less and you'll be on point. Anytime management is requesting for something, you have something to say. But if you don't do tests, you don't record them, you'll be moping. That's why your technician will be telling you all manner of rubbish, things, sorry to say. So it is good you carry out tests when it is due. How do you know that your generator is due? You go to the hour counter, you check, oh, it has run 200 or 250, you service. Your AC has done quarterly operation, you service. So these are the things that help us. We don't manufacture anything, we render service. So you should be able to be closer to what you do. When they ask you a question, what was our last bill for last month? You tell them. Why is the bill going off now? You should be able to know. Last month we're in rainy season. Many people did not use AC. But this month, where the weather is a bit hot, many are using AC. That's why the bill has gone up. So you have record of everything. We don't just go and say we are facility manager. You keep record because you need data to convince your people. So common electrical problem, these are the things you see: flickering bulbs, flickering lights. You see lights blinking and blinking and blinking. And if attention is not paid to it, it will affect the productivity of the people you are serving. You don't expect someone to be working and have a blinking bulb all through the day. The person eyes may be affected. So you pay attention to all of these. This is a table that shows the problem, the root cause, and how you eliminate them. Read this table and master them so that if there's, oh, this boy is not working, it could be a loose connection from the terminal point. What you need to do is to check whether the cable are firm. If they are not firm, get your technician, supervise him to tighten it. So that may just be the cause. Instead of replacing the bulb, it could be resistance, high level of resistance. Maybe they are not maintaining the panel. They just assume the panel. When there is too much debt on a termination point, electricity will not flow because electricity does not require opposition. If the resistance is too much, there will be no current coming to your appliances. So ensure your termination points are firm, are clean, and oiled, as the case may be. Consumption monitoring. Why do you need to monitor your consumption? Many people don't pay attention to what they consume or what the EKDC or IKDC or Bini or whatever give to them. They just accept the bill and present to management for payment. No, you have to monitor your consumption. If one of the places to reduce cost is energy management. Energy management. You can reduce your cost by 70% when you manage your energy properly. So you are employed, you meant that they are paying 10 naira monthly bill, plus diesel about 15 naira. That's when you need to sweep it to action. What can I do to bring down this cost? Maybe people were not paying attention to consumption. Now you are there as an expert, as a professional. You pay attention to consumption. Where do I have waste? Is it that people leave their appliances on, their fan, their sockets, their lights, and so on? You go around. It might be just 1% you have been able to save for the month that you resume. You present to your management. I was paying 15 naira, now I'm paying 14 naira. They will pay attention to you. They will listen to you. And you give them room that there's still room for us to reduce this cost. without compromising standard. All you need to do is to sensitize people and work with them, work with your team. Let them go around and check where you have wastage. So you checkmate those wastage and curb it. Before you know it, your bill will start coming down. You are the one to also present to your management what you are doing. Because if you work like every other person, you are not bringing any value. Sooner or later, they will ask you, what are you even doing? Why do we even need him? But if you have all these things in your fingertip, when they ask you, show them, you do your monthly report, consumption was 30,000 kilowatt hour. Now we are on 25,000 kilowatt hour. They will see the downward reduction. Now we are on 15. Now we are on 20. So they will know that someone has come in who has something to offer. So that's why you pay attention to consumption. So look for any means to bring down your cost through consumption monitoring. And you must present it to your management that this is what you are doing. Nobody will do it for you. You are the one to magnify your office. These are maximum demand meter and the check meter. They perform two different things. The maximum demand meter aggregates the total power in the facility, while the check meter are used to apportion power to individuals where you have multi-tenanted building. So if you are not around, you switch off your check meter. It's not reading. When you come, you put it on, just like the prepaid meter in your house. It's like a check meter. While the maximum demand meter records the volume of energy that comes to the estate or facility. So whatever you have as individuals consumption, we must be aggregated to what you have in the maximum demand, plus or minus, because there will be losses. Very few percentage difference. So that's the difference between maximum demand and check meter. With check meter, the estate is at peace, the facility is at peace. So you, just like your mobile phone, you know how you use your mobile phone. Your Wi-Fi too, your data, you know how you use them. The same thing with check meter. So if you are not around, switch off your distribution board or your control switch. There is no power into your apartment. But when you want to prove that you have money, leave them on, leave everything on. At the end of the month, you are the one paying. But make sure you record it, because most tenants will come to you and say, "Oh, I wasn't around. Why is my bill so high?" Point to their check meter. You don't have control over their check meter. Extra low voltage system. These are important in the facility, just like you need your high voltage. Extra low voltage is very, very important and very, very sensitive. So they must not go down. Like your CCTV, your fire alarm system. You understand? So they must not be faulty. This can lead you into prison or lead to the termination of your job, especially incident happen in a facility and the CCTV could not record it because of battery failure. What do you think your management will do to you? That's negligence. They must make sure they are working. They are the bedrock of every facility in this modern age. Pay attention to them. Go around. How are the battery performing? You note them down. Anyone that needs replacement, you replace it. You don't compromise it. Once the battery starts going down, you replace. If a set of battery, like let's say 4 set of battery, a bank of battery, and one has started going down, replace all of them, because the other 4, the other 3 will soon go down. So you know when to replace them and know when to maintain them. Maintenance first. If they now fail maintenance, you call for replacement. Don't say, oh, they will not approve. If you present your case very well, nobody want to take risk. So they will approve for you. We have transformer, and like I told you, transformer does not produce voltage. They only modify voltage. What produces voltage is the turbine or the alternator. We have transformer of various, the power transformer. So they modify the power that is generated from the down or the electric power station to the value that is required to be transmitted. That's why you have distribution transformer, power transformer, and co on our street. So they help modify the voltage, stabilize the voltage, but they don't generate power. And you must maintain them. If your transformer is not well maintained, your voltage will start having issue. Either it goes down, you have high voltage resistance there and there. Before you know it, start blowing off equipment in the facility. So maintenance is key to our facility. Maintenance is key to our equipment. So when you maintain, you reduce cost. You bring down cost of operation drastically. But most people don't, they say it's working, leave it. Did I complain? No, it's your responsibility to tell them what to do. I've had cases where transformer will be tripping the entire network. They will come, take us off, and others will have like we will not have, because they refuse to carry out maintenance. At the end, when you eventually do that maintenance work, you see that your electricity is stable, the entire network is stable. If you do not do maintenance, maybe on a public transmission, you are affecting other people. You are a nuisance to another people. Ensure you stick to your money. Let them know this is why you are here. You're not here to take their money. It's to prolong the lifespan of the equipment and reduce downtime. So you must know how to do a business case. Everybody in the office have their KPI, what they must show that they have done for the month. If you tell you, oh, I couldn't do it because they said the money was high, because you did not plan yourself very well. So you have to show them why you must do it. If we do this, this thing will not happen. We'll run less on generator. If we don't do this, we run high on generator. And the cost of diesel to the cost of electricity, public supply, we compare it. Which one is beneficial? We present it like that. They will approve it. What is the cost of what's it called? Tariff in band A? About 209 naira. What is the cost of per liter of diesel? About 1,500 or 1,000, yeah, around that 1,200 or 1,300. You do this comparison and send approval, send request for approval. If they don't approve, you have done your part. So that's transformer for you. We have different type of transformer, distribution transformer, where you see on our road. We have the dry set transformer, the one that are used in mill. That is high rises. They are dry set. What they need is cross ventilation. Let there be fresh air coming in. They don't need servicing. They don't no. Yeah, you clean the terminals. They don't need the oil. They don't need the water, and so they just all they need is cross ventilation, like a conventional current. Transformer maintenance, we check daily. It's your technician. Make sure you drive the process. You drive the process. We have monthly maintenance, all you check. These are what you check. Ensure you have a checklist for all of this and give to your technician. You can work with them. You can go around with them, show them, and if they don't do, you have the right to sanction them. But ensure you drive the process. Your own is to drive process. You have process implementation. You implement process. So you don't just leave them to their face. Drive them. They can just go and mark good, whereas nothing is good. Common battery on the generator can sack a facility manager because your technician mark it good. You assume it's good. You must go there and check. Check the terminals. Check the charging points. Are they charged? Are they well contacted? Are they firm? Because technician, they don't have anything to lose. You are the point man. Take all these things seriously. When you need to carry out maintenance, do it. When you need to call for inspection, you do it. Maintenance is very cheap, but people don't do it. They prefer what they call the reactive method. They don't do plan PPM, plan preventive maintenance. They don't do it. Some people want to feel it's not giving me any problem. Why should I do it? It is a responsibility to convince them to do it, because that is industry standard. It's not what they can do, it's what is doable, what is obtainable, what is standard in the industry. All right, a steam transformer, generator and fuel management. What is a generator? A generator is a machine that converts mechanical energy, like I told you when we started this, to electrical energy for use in. They provide almost all the power for electricity. Like I told you, generator is not our main source of electricity, not even the public power. There's a difference between generator and a motor. A motor converts electrical energy to mechanical energy. Why a generator converts mechanical energy into electrical energy? A motor requires current to be driven. Like your fan, your ceiling fan is a motor. Like your fridge is a motor. So anything that takes current is called a motor. Your pumps is a motor. They don't produce electricity on their own. So they depend on external electricity for them to function. So these are pictures of generator, the higher one, the smaller one. This is a three-phase generator. This is a single-phase generator. We have three-phase generator and a single-phase generator. Single-phase generator is a generator that has 2 wires, live and neutral. Why three-phase generator that has 4 wires, live, and neutral. So the generator, three-phase generator produces 415 or 400 as the case may be, while a single-phase generator produces 240 or 220 volts. So generator operates at 50 Hz. As you can see, this is the standard. So plus or minus percentage, I will give you 48 or 52 is tolerable. I told you alternating current generator, they produce power but not clean. It's not as efficient as the direct current. We have the single phase or polyphase generator. A polyphase means generator that has more than 1 wire. A single phase generator, a generator with 2 wires, like live and neutral. They have specified voltage, 220 to 240. 2 or more alternative voltage, that's for polyphase generator. Phases are usually 2, 3, or 6, as the case may be. What I've seen is single phase, 3 phase. I've not seen the 6 phase. We also have this generator of this capacity. This generator is a generator that gives direct current. Direct current generator. That is clean. It's very clean. It's not alternating. It's not sinusoidal. It's alternating. They use them for battery chargers, and where you don't deserve this require distortion, that's when they are mostly used. So most of this time we use a rectifier batteries to make sure our voltage or this power is very, very clean in our factory. When you have clean power, you spend less on repairs, replacement, and the likes. So ensure your power is clean enough to be able to power your equipment. Selection of generator, determine the sum total, like that man said when we started, determine the sum total of the load in your building. Let's, for example, you have let's say this total sum of your load is, let's say 40 watts. You have like 4 air conditioner that is of 10 watts or kilowatts. What you need to do is to aggregate this equipment together and divide it by 0.5 to give you the size of the generator that you want. Can somebody do that for us? So let's just do it now. I told you power factor as a function of load generator sizing. Can you see my screen? Confirm if you can see my screen. I'm on a separate page now, a separate page.
Yes,
Can
sir,
anybody
can see your screen?
Okay,
No,
let's
we
say,
can see generator and fuel management. That's what I can see.
No, sir. We are on
we can't see the exec.
fuel management.
okay. You are still there, Abi?
Yes,
Yes.
sir.
Okay. I wanted to, sorry. All right. Okay. We'll go back to, can you see it now? The Excel, the
sir.
spreadsheet.
Yes, yes. Can see it now.
All right. I want to have a practical experience of how to calculate generator size. Let's say all your AC, they are 2 horsepower, Abi? 2 horsepower. Quantity, items, rating, and quantity. Let's say this is a 5, you understand? Total. Let's say total is this. 2 times 5, I'll give you like, let's do in kilowatt now. Let's say 2 kilowatts. This one will give you like 10 kilowatt, right? I need your participation, right?
Yes, we are with you, sir.
Yes.
10 kilowatt total load
Yes.
is 10 kilowatt. And you have a power factor.
Yes, sir.
Power factor, which is 0.8. This is industry standard. I'm not the one that did it. Everybody came together to agree on this factor. It's called power factor. It's a multiplying factor. So, you know, this is in kilowatt. Your generator, how is it rated? Is it in kVA or a kilowatt?
KVA.
It's KVA.
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 Right? So,
Yes.
to get this in kVA, not be, let's assume this is a kilowatt now. Let me get it. Kilowatt. In kVA now, you have 10 kilowatts, right?
Yeah.
Your generator size for this load now will now be equal to 10, that's the 10 kilowatt now,
Yeah.
divided by your power factor.
Power factor 1.8.
Please write it down.
0.8. Okay.
So you have 12.5 kVA.
12.5.
12.5 kVA.
12.5 kVA.
Can you leave your generator size to be 10.5 as you recommend to your customer?
No.
So,
No.
like I told you, we don't recommend exact value to your customer rating. You do plus or minus 5. No, plus 5 or plus 10%. You understand? This one will now be equal to this times, let's say, 110%. So what you give them is 30.7, let's say 14 kVA or 15 kVA as the case may be. Do you get?
Yes.
Are you with me? I use 10% plus that's 10% allowance. I created 10% allowance. So which will not give you like 15, let's say 14 kVA. Let's say 14 kVA. Right?
No.
Are we together?
Yes,
sir.
sir.
Yes, sir.
So this is how you use your load to determine the size of your generator. The load that is already in the build. If you don't know, in case you want to size for, if the entire load is higher than the size of generator that you have, you can now say, this is the reason why our generator is shutting down when it attains its full load capacity. You understand? So in this case, you have data to convince your management to go for 15 kVA. Nobody will argue this. Is it clear?
Yes.
Yes,
sir.
All right. So this is how you use power factor to determine the size of your cable, of your generator. When you already know what is installed, when you get it correctly, what is installed in your facility, you take them, aggregate them in equipment almost rated in kilowatts. So you have to divide it by 0.8 to get your real kVA. This is the real power. This is apparent power. We can't go in there. Thank you. Is that taken?
Yes, sir.
All right. We're almost running up. We're almost running up. Let me go back to our... Okay. All right. Diesel management is where we are now, and generator management. So when you want to install generator, you know the procedure. You inspect, check any thing that is not uniform, don't compromise standard, ensure you employ the right person, a trained technician or authorized dealer to do all of this for you. So if you cannot do it, are we together?
Yes, sir.
All right.
Yes, sir.
So
Yes,
I told
sir.
you can see wattage here is check before you accept the generator, check whether the wattage, the power rating of that generator conform to what you have determined and recommended. If it's short of that, you have the right to reject the generator until they supply you the right capacity. Never you compromise, because the seller just want to sell, the marketer just want to sell. Once they sell, they will leave you to your problem. You'll be the one running up and down. You cannot come back to your management to say, oh, the generator I requested was not what was delivered, because you are in the chat. You are the person that will receive and make sure installation is done how it's supposed to be done. So safety procedure on generator installation, these are safety procedure. Ensure all of these are observed. Don't compromise standards, because, for example, someone is in his house, you restore a generator and the smoke, the emission from that generator is not coming to his apartment. He will sue you. It's against compliance standard. So you have to make sure everything is done according to industry standard. We have the alternator. We've dwelled on alternator before now. I'll just mention it and we move on. We have alternator, two components are in alternator. We have the stator and the rotor. The stator and the rotor. The rotor is inscribed into the stator and they move in opposite direction. Just like I'm going to, when you get to Shagamu, you are going to Abeokuta, the other person is going to Ijebu. Can they ever meet? No. That is how electricity is produced. They are going in opposite direction. They cannot catch up with each other. So that's how electricity is produced. The rotor is rotating in clockwise direction, while the stator is stationary. It has been designed to rotate in, that is it has been positioned to go against the rotor. So that's how electricity is produced. It is produced under the first and second law of Faraday or Lenz's law. So alternator produces electrical output from mechanical input. Like I told you, electricity is generated from mechanical energy to electrical energy. Because this stator and rotor must be set into motion through mechanical means. That's when you start your generator, your flywheel will rotate, the engine will lubricate, the oil will lubricate, and so on. And heat is emitted from the radiator, exhaust is taking off, combustion, and all those stuff for that motion to continue. As long as there is fuel into the engine, electricity will be produced. As long as that rotor, the rotor is rotating, the flywheel is rotating the rotor, electricity is generated. Right. If you see your turbine, your wind turbine, as you are going, as long as there is breeze blowing that turbine, that fan, something that looks like small helicopter, electricity will be produced. Inside that small helicopter is tons of wire run together. As long as that turbine is rotating, electricity is generated. All right. The stator contains a set of electrical conductors, one in coils that is over an iron. So the rotor produces rotating magnetic field. As they are rotating, they are producing electric field, magnetic, which is now converted to electric field. So we have the fuel injector. These are where the fuel is sprayed into the engine. These are nozzles. So your nozzle must not block. Don't allow water to have contact with your diesel. That's where your nozzle gets contaminated. The teeth will start rusting. Before you know it, they won't be able to spray the quantity of diesel required for them to operate your generator. And it all boils down to when you compromise standard receiving diesel, never you compromise standard. Ensure you carry out all the tests that are meant to be carried out. Do water test, do clarity test, do density test, that's a gravity test, and make sure they are up to standard. A table is there to show you the standard that is accepted in the industry. So we have the cooling system. They withdraw heat from the generator, like your exhaust. If your exhaust is blocked, there will be feedback to your engine. Before you know it, the turbocharger will be affected. And turbocharger is another source of power for the generator. That's where cooling takes place. Fuel to air ratio meets. And once it means more fuel is being injected into the engine. So it's an additional power to the generator. If your turbocharger is bad, the generator performance will be low. Ensure it's expelling how it's supposed to. If the exhaust is blocked, heat it, blow it off, and let there be continuous emission of hot air from the engine. We have cooling system like the radiator. If your radiator is also blocked, it can affect your engine. That's why most people, the gasket, the cylinder head gasket, we get burned. We say, okay, I want to overhaul his generator, the engine is burned. Whereas you didn't carry out full maintenance. Ensure your radiator is clean always. Don't wait for check if the surface is blocked, just like your nose is blocked. What do? You look for where to breathe out. Either you open your mouth down, which is not healthy. So if your radiator is blocked, the engine will look for a way to emit heat. So that's when it goes to either the turbocharger or the gasket head. It will burn off that place. Before you know, the water will start mixing with oil. They'll say, I want to overhaul because you are not doing what you are meant to do. Clean your radiator. It will not take you like 100,000 if it's a bigger generator, or even 50,000 to clean, but you will wait until that generator knock. You will now spend millions. You want to show that you are working. Maintenance is the key to every successful facility manager. Maintenance. Stick to maintenance culture. Practice PPM. So we have the battery. Like I said, a battery can land you into problem. When you are supposed to check the battery level, the voltage level, you didn't pay attention, you assume the generator will come up on its own. We have routine check daily, weekly, monthly, quarterly, biannually, and yearly. All of these, when you put them to work, you bring down cost. And that's when you have the amount to demand for increment or promotion. Because you have record of what you are doing, you document them. Nobody will do it for you. Like I said, you drive process. We are not telling you to go and be doing a technician work, but when it's time for you to do, you do it. So battery, as small as it is very, very key. Ensure it's on standby. It's called standby. Control panel also ensure the connections are firm, they are tight, no loose connection. If there's no connection, there will be open circuit, your generator will not work. That's why somebody will tell you, oh, is this, is that? They will bring computer and start troubleshooting. Whereas it's a simple wire that loses connection. They will come and charge millions. And because of your ignorance or because of lack of attention, you will end up spending millions that you are not supposed to spend. So we are employed to bring value to our facility. All right, these are daily maintenance on generator. You check the oil level. Don't assume, let them check and record it. Sign. This is the checklist. This is the checklist, what you have done for the day. If tomorrow anything that happens and you claim that you've checked it and you discover that the person just do good on all of them, you have the right to sanction the person, or you give them regular training. As you have here now, you have to pass this knowledge to them. It will make you work better, at peace. All they to give you reports. We have this one we're able to do. So don't restrict knowledge. Don't be a team player. Carry your subordinate along. Let them work for you, whether you are there or you are not there. So these are 200 service an hour or 250. You know what to do. You change the oil, you replace fuel filter, you clean up where you are meant to clean, and clear off where you are meant to clear. 500 hours, this is what you do. Check the radiator cap. There may be deposit of debt. That will be tripping the sensor to, and the generator will keep shutting down. So paying attention, pay detailed attention is key in maintenance. Like I said, our duty is to bring down cost, minimize risk. I know risk cannot be eliminated, but you minimize it, you reduce it. And when you do this, your turnover, your profit will go up. If they were spending 100 million before now you came, they are now spending 60 million. You see the difference. You'll be able to say like 40%. You show it to them because of detailed attention that you have paid to your maintenance. Some people compromise. They will say, they've claimed that they have changed oil, whereas they didn't. When the problem comes, you bid one up or down. That's not how to be a fantastic facility manager. What makes you a fantastic manager is ability to stick to standard and drive down cost without compromising anything. All right. So when you do diesel management, you take total control of the diesel consumption. You know consumption pattern, like in the case of electricity, you know consumption pattern. You know how much diesel you consume at a certain percentage load of your generator, like 40%, 25%, 40, 50%, 75%, 100%. When I'm on 100%, what do I consume? Maybe it's a 200 kVA. I consume 10 liters per hour. If I'm on 50%, I consume 50 liters per hour. Because you have record of all of this. So he also give you room on how to reorder diesel. Nobody can bamboozle, oh, your diesel is about to finish. You know when to order. Whether it's on 100 liters, you know, you can predict. This is how it has been. You know when to order. It gives you what's it called? Control over what you do, because you have a pattern. You establish a pattern. Oh, I spent so last year because of this. This year, I'll try and bring it down. These are the things, these are the metrics you'll be showing your management. Because you are not producing anything. You're only rendering service, strategic service. So guard against theft, because that will compromise your value. If they are stealing your diesel, and because you don't have control over it, try and mitigate that. Try and stop it. It won't take anybody anywhere. Rather, it leads to sanction and dismissal from the company. Before and after supply, you check the quantity, what you have in stock, and what they are supplying you. You check the quality, must be proved to be compliant with industry set standard. We have values that we look out for. Density 0. You see the table. So these are the table between this and this. Litmus paper, when you put it there, from red litmus it become pink, or from pink to red if there is water inside. The density, most of us were used to 0.845, 0.5, 0.3, and so 83, and so. So they must not fall below a certain standard, 0.2 gram per cubic. The same thing with the quality. Before, we used to have diesel that looks like purplish color. I don't think we have such diesel again. That was one of my best diesel. Doesn't burn fast and doesn't contaminate your fuel line. Very fine. So ensure you stick to all of this that you have heard today. I would like on break, just like 5 minutes, we'll round up with 80 system. I think this is the last set. When you are back, let me know that you are back. 5 minutes. That you'll be back by 6:37. 6:37 should be on your seat. Thank you. Did you hear me, please?
We do.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Just ease of self. Stand up, stretch. Stand up and stretch yourself, and come back 6:37. Thank you.
Okay, sir. Thank you.
Thank you, sir.
Àti fóònù ti kú tó bá ti tàn máa transfer sí. Jókòjọ́ ọ̀dẹ́ mi àtẹ́jọ́ sọ̀rọ̀ náà gádà mórí ẹ̀. Ẹ ti sún mi lórí fóònù mi kú dáàdì mi náà ló máa ń pè mí. Gádà mórí ẹ̀ nígbà.
All right, you are welcome back. If you are there, I want to hear your response. I want to get your response. You are welcome back to the class, everyone.
Thank you, sir. We are here, sir.
Okay, thank you for your cooperation thus far. It's been smooth. Yeah. Okay, we are in our last slide, which is grounding system, also known as LT system. After all said and done, if you do not have a good LT system arrangement in your facility, it will also cost you more money to run your facility and expose your facility to very high risk of thunder strike and fire outbreak. And also electric shock, all your facilities, including humans that interact with your facility, their lives are at stake. So that's why we lay emphasis on this at the last stage of this topic, this course, so that if you don't have it in place before now, add it to your PPM. Let it be part of your PPM, planned preventive maintenance in your facility. And after this class, you will know, you'll be able to convince your management or your accountant why they should set aside a token for earthing system you're building. What is earthing? A system of cycle that connects part of an electrical circuit to the ground. Everything about your installation, your generator, your transformer, everything in the building must be connected to the ground. That is what we call earthing or grounding. And it is done through a cable. We have what we call earth cable or earth rod. Like you can see here. This is earth rod. This is the cable that is coming. This is the cable that is coming. If you see, look at this picture very well. If you look at this picture very well, the one under, before the Max-Migold logo, you will see that it's like a bond wire, because all abnormal currents or power goes through this place. They go through this place to the earth, and this conductor, this earth rod will take that abnormal voltage or current to the earth. Why? Because the earth is assumed to be at zero potential. No work is done at zero potential, no resistance. Because current, I want to take these points, current flows in a direction of weak resistance. Just like your water. If you place your water on a level playground without bending that train or table, the water will remain there. It's like first law of motion. Said an object will continue in this state of rest until it is altered by external force. So that object will not change direction. It will continue in this state of rest. If you put anything on your table or your bed, put your pillow on your bed without disturbing your pillow will remain there. That's how you mate it. Whether you go abroad and come back, you mate your pillow. The same thing with earth. Earth is at zero potential. It's the weakest part of our installation. That's why any voltage, any abnormal current that is coming will come through the earth. And if your earth is compromised, that's when it is risky. If you have contact with electricity, that's why you see most people, it will pass through their spinal cord. Their spinal cord is the weakest point. Spinal cord is the weakest point in our body, the joint. The current must look for a way to pass out. So what do you do? Is to keep maintaining the value of your earth, like 0 volts and almost zero resistance. If your earth's resistance is going above 2 ohms, know that you need to lower it to where it's supposed to be. What do? You service the earth point. Either the cable is compromised or that surface is heating up, because heat goes through the ground where this rod is pegged. What you need to do is to get electrolyte, that's liquid current in liquid form, like the salt. We call it salt. It's not actually salt. They are electrolyte. Sodium chloride, sodium hydroxide, magnesium chloride, and also there's industrial salt. They are electricity in liquid form. When you put those things in water, that's what gives you your battery, the wet battery, the cell, the anything battery. So they conduct electricity on their own. When you put those things, mix it with water. When you mix it with water, the salt, and pour it there, it will clean up that point. You can also use charcoal and animal waste. What does charcoal do is it helps to absorb impurity in that area that will resist the flow of current. The charcoal it absorbs impurity. It's a cleanser. It will on its own naturally take up the impurity around that earth region. And the animal waste will help to soften that spot, make it so just like your manure. It will help that place to be softer. That's why you see yam and other stuff will go deeper into the soil because that place is soft. If you plant close to the water, to the river, you see how productive your farm produce will be. The same thing with earth. The animal waste will help to soften that place. The charcoal will help to purify the purity, and the salt will increase the conductivity of that point. So if anything is coming, it just goes to the ground direct. It makes it, leave it at zero potential and at zero ohms resistance. So you see why earth cannot be compromised. Some people say, oh, what do we need it for? That's why your board, if those abnormal voltage has no place to escape, they will come back to your building. They will become what's it called? Unusual current. Current that is not required, unwanted current. We start looking for where to go. We'll be moving around until it has a place to escape. It could be your smart TV that you bought with millions of naira. Because I told you, current flows towards a weak resistance. It could be that your smart TV is where the weaker resistance is. It will go there. It could be your other valuable things. But that unwanted current must go out of the installation. It's not part of your installation. And if it doesn't go, it will be there. It causes circulating current. It will increase your bill at the end of the month. So something you could have just avoided by treating your earth system with less than 100,000 is causing you damage. Because you don't know. Now that you know, take this knowledge to your place. Why are we replacing bulb? Someone did a survey with me. Why our things are going bad. Even when I take over a facility, that's the first thing I do. Read your earth. I'll read it. Some will be higher than usual. So what you do, you call for treatment. You service it. Your transformer suffer the same thing. Because electricity comes with current. Just like you are heating up a place where you are cooking, that place becomes solidified. It becomes caked. Nothing passes there. What do? Is to make it soft so that the required current can go through. So that is why earth is very important. If it's not treated, it becomes a nuisance to you, become cost center for you as a facility manager. They will say, why are we spending so much on repairing? Why are we spending so much on this? It's because your earth is compromised. Please let it be part of your PPM. Now that you know. Not everybody knows this. That's the reason, one of the reasons why you are here. Value that you deliver to your organization. When you go back, you are going back refined, purified, with more knowledge on how you manage your facility. This is the difference between you and the people that didn't come here. Are we together? I need your response.
Yes, we are.
Yes, sir.
Yes, sir, we are.
All right. So take it seriously. Maintenance is the key factor in optimizing your facility, bringing down your costs, and minimizing risk when you need to do what you are meant to do. If I'm interviewing people, they'll say, I can do overhauling, I can do this. I will not employ you because you are a saboteur. If you say, oh, I know how to carry out maintenance very well, yes, you know what you are doing. It's not, you cannot lead to repair if you do proper maintenance. Just simple things. Change the battery water when you need to change it. Tighten the terminal head when you need to. Grease it when you need to. Blow off the panel your facility when you need to. You have regular interval. They have interval of doing all of these things. Could be once a year, could be twice a year. IT system, the same thing. Imagine this cable. You can see the head is burning off. A time is coming, this point close to the rod will be resistive. It will not allow flow of current again. The current will go back to its source. I want you to know this. Current tend to go back to its source. Just like when you go out, you must go back to your house. When there is a fault, the current must go back. If your system is not able to trip it open, it must go back either your transformer or to the main station, the substation. I'll round up with this. Why do you think a bird can perch on a live wire without being electrocuted on the same wire? Can anybody tell me? We'll round up with this. Hello, have we closed?
Yeah, with you, sir.
Okay, the reason is this. The bird is on the same wire, the same potential. There is potential, there is no difference in potential. That's why it's able to stand there. It's like there is zero work there. No work is done. Electricity can only flow when the equipment, the tools in place or the equipment in question are of different conductivity, of different value. So the bear is on that wire. There is no work done. Just like the water on the surface of your table, plain table, it will not flow away until you bend it. The same way. That's why electricity is very important. The earth is at zero potential. Zero potential. No work is done. So your installation is higher than the earth. It must flow from a stronger potential to a weaker potential. Your earth is very, very important. Are we together? Any question before we call it a day? We have 10 minutes to ask our question, though we didn't start exactly 5 o'clock, but we're able to meet up with time. So question that will benefit everybody, just 3 or 2 will be fine. 2 or 3 will be fine for today. If you have further questions, you can reach out to me and or reach out to the training manager. So we are there to tackle your question. In no particular order, question that will be beneficial to all of us. Kindly ask your question. Daniel Query spoke before. I want another person to speak. Daniel Aja, you can ask your question that will benefit everybody. After Daniel Aja, you will ask your question.
I can go ahead.
Yes, you can.
Okay. Good evening, sir. Good evening, everyone. Concerning the NEPA system, the FM system aspect. Now, in a situation whereby whenever there is how do we control whenever NEPA comes in, like it comes to its own generator, there is own transformer and everything, the whole system properly set. But sometimes whenever NEPA comes, especially when there is rainfall, or maybe even though the rain has not fallen, so far the weather has changed. the voltage increase.
Okay.
It will just increase on its own. Sometimes it will just drop. So how do we control that? We did not the editing that was done before. Another was added because of the frequent increase in voltage whenever there is rainfall or even the weather adjusting that there is rain want to fall. The voltage will just skyrocket. That is on NEPA alone. So what in such situation, what can we do to correct, despite the fact that an editing system was done, additional editing system to control that? But although it
Okay.
reduced the increase, but it's still the voltage rise, but the voltage is still increasing. Sometimes it's still dropping, but although it has
All right.
reduced drastically, but it's still happening.
All right. Thank you. Yeah, I'll take your question as it comes so that we'll save time. Voltage rise is not about 18. There are maybe you said during rainfall, maybe some people, some company, is this problems localized to your facility or to the entire area? Is it localized to your facility? Hello? Okay, if it's localized to your facility,
Sorry,
you have
sir.
to.
It's like localized.
Okay, to
It's
your
a
own
transformer on its
facility.
own. The company has a transformer and it's on 33 kVA. And on that 33 kVA in that environment, it's only 3 or 4 complaints that are on it.
Okay. Yeah, that's the effect you have expressed is called Ferranti effect. Ferranti effect is instantaneous increase in voltage as if people start dropping their load, maybe the light, you are running on light load at the receiving end, it is called Ferranti effect. What you need to do is to maintain a certain value of load, just like 45% of your load. It will reduce the effect of Ferranti effect. So if it continues, what you need to do is to put such protector in place, make arrangement for such protector that will not allow all voltage relay, under voltage or over voltage relay that will cut off a certain percentage of voltage, a certain volume of voltage. It will not allow into your building, except you don't have those parameters in place. If you have them in place, you set it to a percentage. If the voltage is too high, it will cut it off. If it's too low, that will spoil your equipment too, it will cut it off. So you have to set, just like your stabilizer at home. So it helps to regulate voltage
Yes,
that comes
we
in.
have a system that cuts them.
Okay.
Sorry.
So it's not about earthing now.
Although
It's
we have
not
a system that cuts it off.
it's not about
Whenever it
earthing.
increases,
No, it's not
it's
about
cut off.
earthing now. It's about
And whenever
it's about the people that are picking the
what
load.
about the dropping?
The dropping.
Okay.
The dropping of the load.
How about the dropping?
And it's because it's coming
from the voltage goes.
It's coming from a fireplace. If coming from a fire, like I said, resistance can lead to voltage drop. It could be that as water, the rain is falling, there is flood, so many things, because the cable is coming from underground, right? There may be a contact, that's a short circuit along the line that you may not know. If two cables bridge together, it causes a high voltage or low voltage, as the case may be. So what you need to do is to protect your building from allowing those abnormal voltage to come in. Thank you. All right. David Thomas.
Okay. Mine is just something that I really want to know about. I want you to throw a little light on how DC current work and AC current work, the difference between the two.
Okay. AC current is the current that you get directly from the alternator I explained to you. We call raw power in our facility. How many of you are familiar with our raw power? And the DC current is a voltage that has been modified to work to to flow in a certain direction, just one direction.
Okay.
It's not instantaneous like
It's not instantaneous,
like the alternative current.
Okay.
Like the one you get from battery. That's why they use battery. If you go to major companies, you see banks of battery, a room dedicated, a floor dedicated to battery to get clean power. When you have clean power in your facility, you are saving costs. Things will not go bad easily. That's why they dedicate them to IT equipment. Like I said, one power pack of IT equipment runs into millions. So what you need to do is to have a DC supply, clean power, almost 100% efficient to run your facility. That's the difference. DC goes in one direction. It's called direct current, while AC is instantaneous sinusoidal.
Okay.
All right, thank you. Is that
All right, sir. Yes, sir. Yes, sir. Thank you.
For the Van der Hamzem, sorry if I didn't pronounce your name well. I just wanted to, your hands is up. Ask your question before we call it a.
All right, thank you, sir. My name is Van de Farm Ben.
Okay.
Sir, thank you for the wonderful lecture. The questions I have is
I can't hear you again. Can you hear him?
No.
Okay, he will come back again. Daniel, okay.
Appliances in a building, they already have their own capacitors. So this one that you're talking about different from the ones the systems are already built with?
Yes, if you manage a very big facility, you will see they call it bank of capacity. Just like you have bank of battery in your IT, you have bank of capacity. They help to start up process. Yeah, like it helps your transformer to peak. It helps your other appliances to peak. So the issue is the beauty of it is to bring down cost of energy. Like that, your AC, if the capacitor is bad, I bet you 20 kVA cannot start your generator, your AC, just one AC. But with the help of a capacitor, it helps us to speed up the process of starting. So if you have capacitor bank, maybe when you go on a trip, practical trip, you will see them live. So it's there. It helps to reduce cost of energy and help to speed up starting process in most facilities. So they are dedicated.
Okay, thank you, sir. Then,
all right.
Okay, thank you, sir. Then I also wanted to ask, sir. Sorry, I had another one, sir. Please, this portable appliances testing. In case you are using a control panel that probably you have pumps that are connected to, how do you now conduct that? And what are the values that maybe the technician carrying out that testing should be looking at? Is it the voltage? Is it the current, or is it the resistance?
Yeah, you have a test, an instrument that's called multimeter that performs all these, that has all these parameters. You can test for the resistance level. You can test for the current that is being taken by the appliances, the voltage as well. You can test maybe the one on your generator or your panel is faulty because of interference also. You can use this multimeter to test them. It gives you the exact voltage. It reduces the level of interference or on it. So you test it, it gives you the direct value. So like if you are testing for voltage, you set it within the range. Let's say 250, because you are going to get 240 out. Your voltage might be more than 240. So you set it at 250, you put the terminals there, and it will give you. If it's resistance, the earth resistance, no, you use mega for earth resistance, you set it to a range. So if it's going above 2 ohms, you know that your earth is compromised. So it's a multimeter that can be used for multi-purpose use. Thank you.
Okay, thank you, sir.
All right. A query, the last person, this past 7.
All right, thank you very much, sir.
Welcome.
Thank you for the class. I have 2 questions. The very first one is how someone can know the capacity of circuit breaker to be used on your facility, the capacity of the circuit breaker to be used in your facility. And the second question is concerning the earth treatment. You are using the multimeter to test how functional is your earth. Where will you put the terminals, and what parameter are you using? Is it ohms? Where and where do you put the 2 terminals of the multimeters? Thank you, sir.
You use your first question was circuit breaker, the size of circuit breaker. Like your AC, if you want to protect your AC of 2 horsepower, you have to know the current that AC would require to drive itself. If it's 10 amps that AC required to drive itself, you don't give exact value of that 10 amps as your circuit breaker. You give a clearance, like say 15 or 30 amps. Don't let the allowance to be too much, because if it's a fault, it can open. So you, instead of putting 10 there, you put 15 or 13. So if the fault goes beyond 10, 11, 12, at 13 you should be able to open. It might be transient fault that just come and go. So you don't need to put 10. If you put 10, there will be trip off and on. So you give a tolerance that circuit breaker can withstand before, if it's going to lead to a problem, the circuit breaker will now open. So don't overrate your circuit breaker and don't underrate your circuit. When you talk of earthing, we use mega to measure earth. You place them afar. It's like 3 terminals. You place them afar. One on the, if it's air floors that you are using, like the one they use in the high-rise building, you put one there. The other 2, you set them aside in the area that your earthing is arranged. You put them aside and press your mega. It will give you the exact reading around that place. So if it's ohm meter, that is a resistance, you set it on ohms. Resistivity, you put it on resistance, that is resistivity, you test it. You have a value that should not be more than 2. If it's going above 2 around that place, you know that region needs to be improved on with what I've mentioned to you, the charcoal, the salt, and the animal waste. So if it's voltage, the same thing, you put it on the what's it called, voltmeter, because it's a mega is also a multimeter. You put it on the terminal and the body of where you want the earth to be measured. You set them aside and it will give you exact figure that you are requiring, that is around that place. So that is how you say mega. Maybe when you go on trip, you will see it live. So that is how it is done.
Thank you, sir.
You're welcome. All right. Thank you for your time and patience. And I believe you have something to take home and to your facility. Have a nice day. If you have any question, Miracle, you can reach out to Miracle or reach out to me on my mobile number 080. You taking it out 080 35 10 4509 080 35 10 4509. Have a lovely night. Thank you.
All right. Thank you very much, sir.
Thank you very much, sir.
Thank you all for joining today's section. See you all on Wednesday. Please let's remember to do our assignments. That is the assessment, and make sure to complete them before the next class. And also the feedback surveys. Yeah. All right. Thank you, and have a great night.
Thank you.
Thank you very much.